Hello everyone, welcome to my Data Science and AI channel. My name is Ajitesh and I'm here to bring you the tutorials, latest insights and innovations in the field of data science and AI. So today we are going to learn the concepts related with the cost function of regression, logistic regression model. Whether you're a beginner looking to understand the basics or someone brushing up on concepts, you have come to the right place. Before going further, I would urge you to subscribe to my channel for more informative videos in future. Alright, so let's get started. So, before we go and understand the cost function, it is important to spend some time on what exactly is the logistic regression model. If you already know about it, I would urge you to skip this part and go straight into the portion of the video which talks about the cost function. Alright, so logistic regression model is used to predict the probability whether a certain event happens or not. For example, if you have the diagnostic report for a particular disease, now this is where we'll use the logistic regression model to say what is the probability that a person is suffering from a particular disease. The logistic regression model is often represented using what is shown here, the S-shaped curve. This curve is at the heart of the logistic regression model, and it is also called as the sigmoid function. It is used to calculate the probabilities between 0 and 1 given the input. Now the equation that you are seeing here, which is 1 raised upon 1 plus exponential raised to minus n, this exactly does that. It calculates the probability. It actually takes any value of z, which can be the large positive or the large negative number, and maps this to a value between 0 and 1. You may ask, why is that helpful? Well, in the world of classification problems, where we are trying to categorize the things like whether an email is spam or not, or whether a person is suffering from a disease or not, we need our predictions in terms of the probabilities, that how confident we are in our decision. This curve is how we transform our raw model predictions into those probabilities. Now here you're also seeing a formula, so let's bring in some more of this formula and explain it. You see that logistic regression makes its predictions by calculating a weighted sum of the input features. Now this is where you're seeing the feature as x1, x2 up to xk, and then there is a bias term a, and then you have a set of weights which are from b1 to bk, which actually determines how much influence each feature has on the outcome. Now we go ahead and first calculate the weighted sum, and then we feed this weighted sum into the sigmoid function which I have spoken a little earlier. This is where the magic happens. The sigmoid function translates our sum into a probability, a number between 0 and 1. If this probability is higher than a certain threshold, for example 0.5, we might say that the event has happened. Or for example, if you are classifying the email as spam, we'll say that this email is spam. If it is lower than the threshold, we say that the event has not happened. Now, how do we know how good our logistic regression model is? So now we have all the weights, we have identified features, and we have identified the sigmoid function, which is representing logistic regression model. But whether this model is a good model or not, that's where the cost function comes in. In the next section, we'll go and explore what is the cost function of the logistic regression model. Now that we learned how the logistic regression model uses the sigmoid function to predict probabilities, let's go and look into how we ensure these predictions are as accurate as they can be. And this is where the concept of cost function or the loss function comes into picture. The cost function is nothing but it actually represents the difference between the model predicted value and the actual value. If you want to learn more about it, you would want to look at one of my earlier videos which I've posted on the cost function. So if you see, I have shown the formula as well as the cost function versus estimated probability plot on the screen. The curve actually tells us how well the model is doing by giving us the cost of our prediction. The goal is simple. We want to minimize the cost. Now let's first look at the formula and then we'll also go and explain the plot. If you see, the formula might look very complex, but it's very elegant and interesting. J theta represents the cost function. It is an average penalty over all predictions. We sum up the penalties across our training examples, which is indicated by the summation symbol. Here the M stands for the total number of training example. YI is the actual label of the training example, which will take the value of either 1 or the 0 for the binary classification problem. And PI is the estimated probability that the outcome is 1 or the positive class. Now let's go and understand this a bit more. For each training example, if the actual label is 1, the left part of the formula comes into play. We use the left part of the summation, which involves minus log pi because the value of y is 1. This part penalizes the model more as the predicted probability stays away from 1. We'll go and look into this with examples in a moment. Conversely, if the actual label is 0 or the negative class, then the left part actually becomes 0 because yi is 0. Then we come into the right part of the equation, and what comes into picture is it becomes minus log 1 minus p. This penalizes the prediction if it is far from 0. What's really interesting is how this function captures the essence of logistic regression. By correctly predicting the actual level with high confidence yields a low cost, while being wrong with high confidence is very costly. Now let's go and understand this cost function versus estimated probability plot. If you see, the x-axis of this plot is the estimated probability of the positive class. Note, it is the positive class. If you see the y-axis, this is value of the cost function. Now on this plot, you see there is a green curve and there is a red curve. The green curve represents the cost function for the positive class, and we'll understand it in a better manner in a moment. And the red curve represents the cost function curve for the negative class. Let's go and first understand the green curve for the positive class. If it is positive class and estimated probability is low, the cost should be very high, and that's what is actually being shown here in the plot. But as the estimated probability closes to 1, which is same as what is the actual class is, then the cost would be very less. Similarly, now let's understand the red curve. If the estimated probability for the positive class is less, and if it is actually a negative class, well, that's what we want, so cost will be less. But as we move closer to 1, if the estimated probability for the positive, that it is a positive class, is high, but actually it is negative class, the cost function has to be high. So that's where you see there is the red curve basically shows at a higher point. So if you see both the green curve and the red curve, this forms the cost function plot of the logistic regression model. Now that we have discussed this, let's go and explain it a little further. We'll take each of the curve one by one, see it with the example of actual data, and understand it in a better manner. Let's look at how the output of cost function of logistic regression model looks like for the positive class. In a moment, we'll also look the same for the negative class as well. On the screen, you have got a dataset on the left side and a curve on the right side. The dataset shows us some key figures, while the curve gives us a visual story related with this data. Now let's first understand the dataset, and then we'll look into the plot. So there are 4 columns here. One is estimated probability, which is P, then there's a log P, there's a minus log P, and then there's a cost function. The estimated probability P is the probability for the positive class. When we predict that something will happen, like whether an email is a spam or not, this is the model saying that I am sure about it with this certainty, and that's the value of estimated probability. But how sure is sure? This is where the second column comes into picture. The second column, log P, is a way of transforming our confidence levels to work nicely with maths, especially when the probabilities are really small. Notice that when the estimated probability is low, our log P is a large negative number. Now comes the third column, which is minus log P. It actually flips things around. So for a low estimated probability, which is a bad prediction for the positive outcome that actually occurred, what we need is a high cost, and this is where when we go and take a negative of log P, it results in high cost. And finally, the last column is the cost function, which is same as what we are saying as a minus log P. Now let's look at the plot. This is a plot of the cost function value versus the estimated probability for the positive class. Now if the estimated probability for the positive class is less, although the class is positive, the cost function value has to be very high, and that's what is shown here. But as we continue to move on to have the higher estimated probability value closer to 1, the cost function value will actually reduce and become very close to 0. So this is what it is. Now as you look from the table and the plot, you'll find that in the table we have gone ahead and taken the probability from 0.01 right up to 0.99, and you see the cost will actually be higher at a lower estimated probability for the positive class, and when our estimated probability is high for the positive class, while it is a positive class, the cost will be less, and that's what is shown in the table and the plot. So let's go and summarize. We'll learn how the cost function in logistic regression penalizes the wrong predictions for the positive class. Lower estimated probabilities for the positive class yield a higher cost, as we have seen in the plot. And the cost decreases as the model confidence in the positive outcome increases, as seen in the descending curve representing the cost function. Now let's look at the cost function output for the negative class. As we have seen for the positive class, here also we have a table on the left side and a curve on the right side. The table on the left side has the estimated probability as the first column. We are focusing on the negative class. We are more interested in 1 minus p, which is the likelihood of the negative class according to our model. So the second column, log 1 minus p, is the log transformation of that probability. And the magic happens in the third column, which is minus log 1 minus p. This is where we see the cost of predicting a negative outcome. It's a mirror image of what we have seen a movement back with the positive class. If the model predicts a low probability for the positive class while the actual value of the class is negative, this is as per what we really desire, and the cost will be less. That's what is shown in the red curve. At the lower value of the estimated probability, cost function is less, and that's shown in the left side of this plot. But as the estimated probability increases while it is actually the negative class, the value of cost function will continue to increase, and that's what it is shown how the curve increases as we move towards the right. So this is what is the cost function for the negative class. Now let's go ahead and summarize what we have learned. Here we are seeing the cost function versus estimated probability plot for the logistic regression model, followed by the formula that we have seen earlier. On one axis we have the estimated probability for the positive class, and on the other we have the cost associated with the prediction. The green curve represents the cost when the actual outcome is positive, while the red curve represents the cost when the actual outcome is negative. As we discussed earlier, for the positive class, the cost decreases as the model confidence in the positive outcome increases, and that is depicted by higher value of estimated probability. That's where the downward slope of the green curve comes into picture. Now let's look at the red curve. We see the inverse for the negative class. Here the cost soars as the model confidence in the positive outcome increases, which is the exact opposite of what we want when the actual outcome is negative. It's the model way of letting us know, hey, you are getting this wrong and with too much confidence. And the formula that you see is basically the formula of the cost function as we have seen it earlier. So that's all for today. If you have enjoyed the overview of the cost function of logistic regression, hit the like button, subscribe, or hit the bell so you won't miss our next video on machine learning. Keep those comments and questions showing up, and let's continue to demystify the world of data science and AI. Thank you very much for your time. Have a nice day.